Corsi here. In this question, we're told that electricity in a spacecraft can be produced by a type of nuclear generator. We're given a formula that indicates the amount of power in watts that can be produced, and it's 120 times E raised to this negative power, and T is the length of time after the generator starts. So presumably after many years the generator will produce less power. So first of all, it says determine the electrical power initially produced by the generator. That'll be before any time has elapsed at all. So when t equals 0, the power produced by this generator will be e to the negative 0.0079 times 0. Well, that's 120 times e to the 0. Any positive number to the power 0 is going to be 1. So it's 120 times 1, which is 120 watts. So at the start of proceedings, the generator is producing 120 watts of power. Now it says in part B, let's have a look at part B, calculate how long it takes, find T in other words, for the electrical power produced by the generator to reduce by 15%. So we know it starts off at 120 and it's to be reduced by 15%. In other words, 85% remains. We have to multiply by 0.85. That's finding 80% of that. So if we compare finding 85% of 120, compare that with the formula we've got, which is e to the times e to the negative 0.0079t, then you notice that these two have to be equal. We have to get this factor of e to the negative 0.0079t to be equal to 0.85. That would produce a reduction of 15% on the initial 120. So here's a power statement. Let's write it as a log statement. Log to the base e of 0.85 is equal to negative 0.0079t. So to get t on its own, we'll divide both sides by the coefficient of t. So t is equal to log to the base e 0.85 divided by negative 0.0079. Now there's no way of doing that without recourse to your calculator. So let's try that. The log to the base e, that's the natural log, ln, natural log of 0.85. That has to be divided by, let's put this in brackets, the negative of 0.0079. And that produces an answer of 20.572 and so on. So what does that mean? This is T. T, remember, was measured in years. How long does it take for the electrical power produced to be reduced by 15%? So it takes approximately 20.6 years for a 15% reduction in power. How accurate is that? That's to 1 decimal place. So you could produce 21 years to the nearest year, if you like. That would be perfectly valid. But I've got 20.6 years. That's Mr. Corsi signing out. Hope you enjoyed the video.